2, 1.
Welcome again to this online class. In this class, we'll study about reflexivity, symmetricity, and transitivity. Okay, these are the property of relation, and also we try to represent the graphical representation of all these three properties. Okay, move to the next one. We have first of all relation. So for relation, there are some basic terms like we have order pair. Next we have Cartesian product, and finally we have relation. So first of all, go through the Cartesian product and order pair. So order pair, pairs having or two number, okay, we can say first element as A and second element as B, and when they are written as A bracket B, like written as A and B, then this is said to be what? Cartesian product. Okay, we can write any number, we can write 1, 2, okay. So here also this is the Cartesian product. So here our first element is 1, the second element is 2. So in this way we can say that order pair. Okay, next we have Cartesian product. And this, what is Cartesian product? Suppose we have two types of set, okay, two types of set A and set B, and when we do the product, okay, simply product, okay, but not the numeric product, this is a Cartesian product. So in this, what will actually happen, the first one is A, suppose first one is A and the second one is set B, then A multiply B or A cross B will be what? The first element will be from A and the second element will be from B. In this way, the order pair is generated, and this is said to be what? Cartesian product. Next, relation. And a relation from set A to B. Okay, this is a relation from set A to B, and then their subset is formed from Cartesian product. When you take the Cartesian product, subset from a Cartesian product, and then there are relation form, there are some subset form. That subset is said to be actually a relation, and this is denoted by R. Okay, and what is actually happening here, the first element of the order pair from AB is domain, and the second element of the order pair is said to be image or range. Okay, these are the basic things we have discussed. Now there are some types of relation also. We can say inverse relation and identity relation. Inverse relation is actually what? Like suppose we have AB and then there is also BA, so this is said to be inverse relation. And identity relation is actually, suppose we have 1 and 1, so this is said to be identity relation. So the product between A to A, okay, but the element must be same, then that is said to be what? Identity relation. Now move forward for the properties of relation. The first one is the reflexivity, and in this reflexive relation, okay, reflexive relation, what will happen actually, a relation on set A is reflexive if A related to A. Okay, here is actually what actually happening here, element A is making relation with element A, okay, making relation with itself, then we can say that is a reflexive relation, or this is said to be what? Reflexivity. Okay, next we have some example here. Like in this example, we have 1, 1, 2, 2, okay, and we have an extra element 1, 2, okay. So for this 1, 2, we can say that this is not a reflexivity element, because this is in between 1, 2, okay. A is equal to 1, 2, and where A have also same relation, and 1 has also same relation, and 2 have also same relation, 1, 1 and 2, 2. So this is said to be what? Reflexive relation. Next, here is another example which is not actually saying the reflexivity, because in this A is 1, 2, 3, but in this relation there is not 3, 3. That's why this is not said to be reflexive relation. Okay. Now, when we going to represent this reflexivity in graph, it's actually every node will have an arc back to itself. what actually happens, suppose I have a point and then I am maybe moving back to same point, then that type of graph is said to be what? Reflexive relation graph. Okay, reflexive relation graph. And here is some example given. We can clearly observe in the graph that the first one, there is a 4 nodes, okay, and the all 4 nodes is reflecting back to itself. Then the first graph is said to be what? Reflexive relation showing graph. Okay, next one also the both have returning graph. Third has also the both nodes has a returning arrow, and the third has also there is a 3 points and the 3 nodes, and 3 nodes have returning arrows. That's why the all 4 graph is showing that they are the graph of reflexivity and they are reflexive relation. Okay, next property we have symmetricity, or we can also say symmetric property. Okay, so symmetric property exactly is that when is a element is making relation with B, so there must be B is also related to A, then that type of relation is said to be symmetric relation. Okay, now here are some example. We say that R3 is equal to 1 1 1 2 2 1 and 2 1 and 2 2. So actually what happening here, 1 is related to 1, again 1 is related to 1, 1 is related to 2 and 2 is related to 1. So these are making A to B and B to A. That's why this is a symmetric relation example. Okay, next other example we have the same line. So when we're going to represent in graph or diagram, we say that every edge between a distinct vertices. So we have edge for a 2 vertices. Okay, and when point A going to B, so there must be B going to A. Then this type of graph is said to be what? Symmetric relation or symmetricity. Okay, now some example graph is given here. Like in first graph, A is going to B, A is going to B, and B is again coming back to A. Okay, so this is an example of symmetric relation. In second graph also the all points have 1 2 3 4, the all have coming back and coming go. Okay, these are the name as A B C D, and the all is going and returning also. So this is also an example of symmetric relation. And the last one also. Okay, now moving forward, we have transitivity property of relation. Okay, we can also say transitive relation. So transitive relation is actually said to be like that when A is relation with B and B is relation to C, then there must be a relation which show that A related to C. Okay, for each and every all. Okay, whenever what the element is and what the relation is given there, there must be A related to B and B related to C. For that there must be A related to C. Then only that type of relation is said to be transitive relation. Okay, now here is some example also. 1 related to 2, 2 related to 1, so that's why 1 is related to 1 also. Now in the same way we can say that 2 related to 1 and 1 related to 2, so there 2 related to 2 also here is a relation. So that's why you can say that is a transitive relation. Other example is also we can go through that. Okay, when we move to represent transitive relation in graph, there like this, whenever there is a directed edge from a vertex A to a vertex B. Okay, this is a vertex A. Okay, and another vertex B, there is a direction edges. Okay, next other from a vertex B to a vertex C, and then there also a directed edge from A to C, then that type of relation graph is said to be transitive relation. Okay, now let's go through an example like this. Here from A, first of all from A to going B, and again this from B to going C, and in same way C is going back to A. That's why this is a type of transitive relation. In second example also you can do and verify whether it is a transitive relation or not. Okay, and third example also, like in third example also it is saying that the all point, okay, the all point is interconnected to each other. Okay, like this point is going to the second one and is again going to here, so that's why this must be related to the last one. Okay, so in this way we can say that this is also a graph of a transitive relation. And at last we have equivalency relation in graph, and here are some property and some example and what actually happened in the graph. Okay, so first one is reflexivity, and reflexivity say that A is related to A, then that is a reflexivity relation. And every node in graph, what actually happen, in every graph will have an arc back to itself, then that is said to be reflexivity. Okay, symmetricity in same way, it's A going to B implies B going to A, then that is a symmetricity graph or symmetric relation. So for this, every edge between a distinct vertices in the diagram, there must be an edge in opposite direction, then that is said to be what? Symmetric graph or symmetric relation. And at last we have transitive relation. In transitive relation, it is saying that A and B are in relation, then B and C are in relation, then there must be A and C must be in relation. Okay, so whenever a directed is from A to B and B to C, then there must be a direction from A to C, then that is a graph of transitivity. Okay, this is a summary, this is a well summary of all we have done in previous 3 slides. Okay, and now at last we are going to represent some example. Okay, so here is some example, and this is a task for you to verify that whether these 4 graphs are equivalence relation or not. It is showing equivalence relation or not, how it is showing the all 3 types of relation like symmetricity, reflexive and transitivity. Okay, if all the graphs show the all 3 property, then we can say that is a graph of equivalence relation. Okay, thank you all, see you in next